Alright guys, welcome to Weld 56, Unit 1. Um, this unit's pretty simple. We're just going over lines. There's a lot of different types of lines that you can find in drawings, so we got to learn how to identify these lines and then go over some of the basic views. Alright, so point 1, identify the different views of a multi-view drawing, and then the features of a part of an orthographic drawing. So again, different types of drawings, different styles. We'll go through some of the more common ones and make sure you guys understand which is which. To interpret the function of given lines in a drawing based on the characteristics of lines. And lastly, compare and contrast common features of a part in both orthographic and isometric drawings. So if all that sounds like a bunch of gobbledygook, then pay attention. That's what we're going to be going over in this unit. So let's get into it. Okay, so our first set of line types, right? Different types of lines. It's going to be an object line. This is basically, if you're looking at a drawing, if you've ever messed around with like SolidWorks or Onshape or AutoCAD, any of those 2 or 3D design programs, the object line is basically the part. Just think about the part, and you can kind of change the views around, but the outline, okay, like what identifies the parts, those are called object lines. All right, they're thick, heavy lines that represent the main lines of the outside for the part being constructed. These are used to help visualize the outline of the part. This is kind of what gives it shape visually to us. It's sometimes referred to as visible lines. Okay, so object lines, also known as visible lines. Hint, hint, might be one of those quiz questions. The next set of lines is going to be hidden lines. Okay, so these are represented as a symmetrical pattern of breaks in the line. Okay, and these identify things that would otherwise be unable to be seen by your eyes, basically. So it gives you the X-ray vision needed to see edges of the part while at the same time looking through the part. Okay, so imagine this is like a cylinder, right? You would have the exterior wall of that cylinder visible to the eyes, but the inside of that wall would not. So this gives you a visual representation of the wall thickness of that pipe or tubing or whatever. Okay, but obviously you will not be able to see this edge because it's inside. So you use a hidden line to denote that that's not on the outside of the part. It's obstructed by something, but this shape is there. Okay, so this would be like the ID of the pipe and then the OD of the pipe. All right, so that's what a hidden line is. These are medium thickness dashed lines showing the edges of a part not visible to the eye. So this is a good example of it. Just imagine that this is a piece of pipe, but you can see the inside and the outside diameter at the same time. Okay, then you have center lines, thin lines composed of alternating long and short dashes, so long, short, long, short, long, short. And these denote centers of circles and radiuses, things like that. Circles, holes, arcs, and circles. Okay, so this is just the center line. Sometimes you're taking measurements off of center, especially when you're dealing with circles, rather than edge to edge. Certain cases, yeah, you might be measuring off the edge, but most of the time that you have holes, you're going to be going off center measurements. And so that's going to be like your reference point for measuring. Then we have dimension lines. So this is a thin, solid lines with the arrowheads on each end. All right, so this example right here, this is telling me 8 inches from this outer edge to this outer edge. All right, so this is the dimension line. They are used in conjunction with extension lines. All right, those are what's referencing the edge that's being measured. Touch the extension lines and have the relevant measurement within the middle of the line. Okay, so measurement, dimension line, extension line. And now our extension lines. These are the thin lines used with dimension lines. Boom, boom, right there. They extend beyond the boundary lines being dimensioned. All right, just to keep it organized and tidy so we know what exactly specifically that 8 inches is being measured to what 2 points. And we have our leader lines. All right, this is a thin straight line with an arrow on one end. Okay. Some have solid dots on the end instead of an arrow. Okay, points to the surface of a part to show a specific detail or dimension or a special note. Okay, so this can be a few different things, right? This is telling us that's a 3/4 inch hole. You could also use this, boom, like if you wanted to say denote drill to something specific, you could use one of these. So this is for a detail or a note, so a little more vague. Then we have cutting plane lines. All right, these are heavy dashed lines made up of sets of one long dash and two short dashes. So one long, short, one long, short. They end in a 90-degree angle with an arrow at the end of each line, and this indicates where an imaginary cut would produce a cross section identified with the same letters as the cutting plane line. So at the top of that arrow, you've got that letter B, that letter B. That's telling you that there's another spot on that drawing with a B, a reference. All right. And when you go to that reference, this cutting plane line will look like this. All right. So we've made an imaginary cut. So this is a part that is in the drawing been cut in half. All right. So that's what the cutting plane line would be denoting. And then you have section lines. So these are all the diagonal lines, giving this almost like a fill in. All right. These can figure in several ways to show different materials. So used with a cutting plane line to show the surface of an imaginary cut. This is also known as cross hatching. Chain lines. Okay, these are heavy, alternating long and short dashes. They indicate a surface area requiring additional treatment and should begin with a long dash. Break lines, these are used to shorten a part so they can fit on one page. So just imagine the actual dimension of this is like tens or maybe hundreds of feet long. All right, but you have a lot of smaller stuff, medium sized, large stuff all over the drawing. So to keep everything proportionate, this would take up a ton of space on that drawing. So instead of having the full length in there, you do a break line. So that's what these jagged lines are right here. And that just means that this section is just a continuation of what you're seeing right here and right here. And so there's no additional information needed on that part. So you use a break line. This is what the end of the part would look like, and that just saves all the space that you can. Okay? They both look like zigzag lines. All right? And they cutting the part in half is kind of what it looks like. And there's an example of a short break line right there. So phantom lines, these show the different positions of parts that move. All right? Light, consistent dashes. One long, two short, one long, two short. Typically reference how the part is being fabricated, how it fits up to another part. Okay? So if this was like a box that had some sort of motor or something and it rotated, boom, you would denote that there's movement. Okay? That part moves. All right, so an orthographic projection. This helps us understand the relationship between a physical part and the drawing of the part. So this is where you take a multi-view drawing and you turn it into a 3D object. Okay, so a good way to think about this is you imagine it's in a clear box and you're looking at the front view, and then obviously you're going to have every side of that cube a different viewpoint of that part. Okay, so that's an orthographic projection. A multi-view drawing, so this is composed of more than one view of the part. This shows each side of a part, all right, to help imagine the construction process of the part. Usually it contains 3 views: the front view, the right side view, and the top view. Two view drawings usually include the front view and either the top view or the right side view. So this is going to be a 2D drawing, and you're just going to get the front view, the right side view, and the top view. That's usually how it goes, unless you need detail on like the left side, then you would just swap left to right. And if you don't need extra detail, then they'll even do a 2 view. So you're just getting the front and either top or right side. It just depends on how detailed that part is, how much information you need. But this is a great way to kind of get a condensed, simple view of the part and just a small drawing. All right, so this is what that would look like. You got your front view, your top, and your right side view. Okay, and that gives us all the information we need outside of like the actual dimensions that aren't listed. All right, so views almost always orientated in the same layout. Okay, if it's always going to have the front view. All right, always, and it's always going to be top, right, left, bottom, and then second one down would be the back. All right, so regardless of what it looks like in the 3D rendering, a multi-view drawing is always going to be front, top, right, left. Okay, just remember that. Each rotated 90 degrees. So each one of these directions is just a 90-degree angle offset from the front view. Okay, front view most likely to show the most detail. All right, the front view is not always the functional front of the part. All right, so it's about the details. So this might be the back end of the part, but in the view, it's the front if it shows the most detail. Lines in different views always line up with each other. So the left wall, line up, the bottom, line up, right side, line up. So they're proportional to each other. They're always like perfectly symmetrical and square to each other. Okay, depending on which way you're going off that front view. Right, and so now you can kind of see top view, front view, right view, bottom view, back view, left side view or left hand view, right? And all together that would give you an orthographic projection. Okay. Then you'd also, like we mentioned earlier, a bottom view, left side view, rear view. Sometimes if you need extra detail, maybe there's something unique about one of those sides, then you would include one of these if that was the only way to kind of convey the detail of that part. So it's meant to be done in as little views as possible. All right, last slide here. So sketching, this is a term used, or a skill, I guess, used out in industry. Sketching is basically just anything that you're getting like your soapstone or a pen and or just like writing on the ground using a pencil or like a Sharpie or something like that, and you're just kind of freehand drawing up parts. Like nothing's to scale, nothing's really proportionate, but it's giving you all those references that you need to maybe make a part or edit a part or something like that out in the shop. Okay, just simple freehand drawings that quickly depict the part or an assembly of parts. All right, so just that's a term. Don't forget about it. Again, might be on the quiz. So that's the end of this one. So I'll see you guys in Unit 2.